For the extra Chapter 15 problems, we look at number 4, which is asking to compare the wavelength of absorption for these two carbonyl compounds that have carbon-carbon double bonds. And we want to use resonance to explain why the first structure has a higher wavelength than the one that is conjugated. So something that is conjugated means that there's two double bonds in a row. This would not be conjugated because there's an sp3 carbon here separating those two double bonds. So in the first structure, the wavelength is 1650. This is not conjugated. And in this one, it is conjugated. And what we can see is if we drew a resonance structure here, we would have a positive charge here and an O minus there. Our overall charge is neutral as it was in the first structure, but here you can see this has some C.O character, like you would see in a C double bond O, and those show up between 1000 to 1300, so that's going to lower the energy there and have a lower wavelength. In question number 6, each of the following spectra, we're determining if it is consistent with a ketone, an alcohol, a carboxylic acid, primary amine, or a secondary amine. So just a refresher here, a ketone is a carbon double bond oxygen with two carbons on either side. This is an alcohol. This is a carboxylic acid. Primary amine and a secondary amine. And in the first structure A here, if I look at this, I am looking at this peak at 16 to 1700. It looks like 1700. This is a carbonyl, and I don't see this carboxylic acid here should have an OH, not an OR. And I don't see the OH here from the carboxylic acid, so I would say that this is consistent with a ketone. In B, I see the same C double bond O, but now I have this big mess over here, so this is the carboxylic acid. In C, I can see what looks like one tooth. And I don't see any carbonyl functional groups, so this would be a secondary amine. And this one has the two teeth in the right spot. That one is a primary amine. And I'm looking at here another C double bond O. So this would be a ketone. And this is an alcohol. Number 14, which of these would be diagnostic for IR? I would see here this CH, the SPCH around 3300. I would see this and this C triple bond C around 2200. There'd be an sp2CH here around 3050. And here I would get a carbonyl around 1700. And then you might see some sp3 CHs at less than 3000. Identify how IR spectroscopy might be used to monitor the progress of each of these reactions. In A here, at the beginning we would see this sp2CH around 3050, and this structure here would only have sp3CHs. In B, we would have the alcohol broad stretch around 3400. And then in the product, we would see a carbonyl around 1700. In number 11, for each of the following compounds, use the nitrogen rule to determine whether the molecular weight should be even or odd. Calculate the expected mass to charge value for the molecular ion. This would have an even mass because there's no nitrogens. The molecular formula is C5H8O2. So to calculate the mass, we would have C be 5 times 12.011. H is 8 times 1.0009. O would be 2 times 15.99. And the mass of this one would be 100.06. This mass of C is odd. We have C 6H15N. And you can add up the mass the same way. This one is 101.15. This would have an even mass because there's an even number of nitrogens. C6H14 and 2. This one is 114.2. Alright, so to calculate the degree of unsaturation here, we use the formula of 1/2 2n plus 2 plus n minus h minus x, and that will equal the number of degrees of unsaturation. So for this one, this one would be 2 RdBs, and this one is 8. This one is 1 RdB. This is 1 RdB. So each of these has a site of unsaturation. It could be a ring or a double bond, or in this case of C, can be a ring and or a double bond, or 2 rings or 2 double bonds. Number 17, propose all possible structures for a compound with a molecular formula C4H8O that has a signal at 1720 in its IR spectrum. I start with C4H8O and calculate the sites of unsaturation. I have 1 ring or double bond, and the clue of 1720 tells me I have a carbonyl in the structure, and that will be my structure. That will be my site of unsaturation. There's a couple of possible structures. You can have the aldehyde. You can have a constitutional isomer of this aldehyde. You could have the ketone. And that's pretty much it. So there's 3 possible structures, and with only IR, it would be hard to decipher which one of these structures it would be. Number 18, propose a structure for a compound with the molecular formula C4H8O. So that formula is the same one from the last slide. So we have 1 ring or double bond. And we have a broad signal between 3200 and 3600 in the IR, and has no signals between 1600 and 1850. So the 3200 clue leads me to believe we have an OH and not a carboxylic acid, because there's no peaks between 1600 and 1850. So my structure can be, it has a ring or double bond. So I can have a ring with an OH. I can have a 3-membered ring with an OH. a 3-membered ring with an OH where it's on the same carbon as that one. So those are 3 structures that are possible there. In number 21, compare the structure of cyclohexane, which looks like this, with 2-methyl-2-pentene, which is this structure. What is the molecular formula of each compound? This is C6H12, C6H12. The HDI of each is 1. Can high-res mass be used to distinguish these? No, because it has the same formula. How could we differentiate these using IR? Well, cyclohexane has only sp3 CHs at less than 3,000. And this other structure is going to have sp2 CHs around 3050. Okay, so for this IR spectrum, indicate which of the 4 compounds is responsible. In this one here, this is 1500. So I'm not looking at a carbonyl here. There's a tiny blip here at 2000, which leads me to believe that this is A. So I have these sp3 CHs and nothing else on the lower end here. It's definitely not an alcohol or a carboxylic acid, and I don't see a strong peak for this CH there at the end of the alkyne. This one here is definitely an alcohol. There's definitely an OH there. In this structure here, I have a strong peak for the C triple bond C, and there's this one here for the C triple bond CH. So this is that structure right there, and I must have skipped over this one. This one is the carboxylic acid. So this is the OH from the carboxylic acid. This is the C double bond O.